Okay, if this is a ideal diode, then its IV characteristic curve would have looked like this: a perfect horizontal line here, and then a perfect vertical line here. What this means is an ideal diode under reverse bias will have zero currents flowing through it, but the tiniest forward bias applied to it will result in the diode turning on and having a resistance of 0. Obviously, what is shown here is the IV characteristic of a non-ideal diode. So notice that when it's under reverse bias, there's a small, very small, but non-zero reverse current. Also, it takes about 0.6 volts before the diode begins to turn on. So before the forward bias reaches 0.6 volt, the resistance of the diode is actually infinite. Alright, but after 0.6 volt, you can see that the V to I ratio gets smaller and smaller, so the diode's resistance becomes smaller and smaller as the forward bias increases. As I said, the resistance of the diode is simply the ratio of the PD across the diode and the currents through the diode. For example, at 1.2 volt, when 1.2 volts is applied through the diode, we have 1.2 milliamps flowing through the diode. So at 1.2 volts of forward bias, the resistance of the diode is about 1.2 volt divided by about 1.2 milliamps, which is about 1000 ohms. Okay.